Let's look at this set. 7 candidates, namely Ashok, Jitesh, Pravesh, Kalash, Ragini, Sheila, and Hakim, contested for the post of President of the Student Union in Delhi University. In round 1, if any candidate gets more than 50% of the total number of votes cast in that round, he or she is declared the winner. Else, top 5 candidates based on the number of votes move to round 2. So from 7, we are reducing the field to 5. In round 2, if any candidate gets more than 50% of the total number of votes cast in that round, he is declared the winner. Else, top 3 candidates based on the number of votes move to round 3. Okay. Again, we are reducing the field. First, in round 1, you have 7 people. In round 2, you have 5 people. In round 3, you have 3 people. In round 3, the candidate who gets the maximum number of votes out of the total number of votes cast in that round is declared the winner. So see, in round 1 and round 2, you have the additional condition. It has to be more than 50%. In round 3, it is simply whoever has the maximum number of votes. Even if you have like 1/3 plus 1, from the total, you have 1/3 plus 1, you will be declared the winner. Okay. In any round, no two candidates got the same number of votes. And this is an amazingly critical line. This is what will make this set solvable or unsolvable. The table below shows the number of votes received by the candidates in round 1 of the election. We have 7 people. We have the total number of votes achieved by them. Okay, absolutely wonderful. Now, based on this, lots of votes have been cast. Nobody's clearly crossing the 50% mark. Nobody's crossing the 50% mark. So 2 people will get eliminated. The 2 people who will get eliminated are Hakim and Ashok. These are the 2 people who have got the least number of votes. Everyone else survives. But what happened in round 2? What happened in round 3? We are not told. In fact, the clue for the idea that you wouldn't get to know it is clear from the first word of the subparts that you can see, if, which means there are cases to be checked with different conditions and different situations. You have to solve all over again repeatedly. Let's go. If 15,000 votes were cast in round 2, then the value of the sum of the number of votes received by the candidates who got the maximum votes and the number of votes received by the candidate who got the minimum votes in that round could not be less than. Okay, let's see. 15,000 votes were cast in round 2. So I'm saying, let's say the 5 candidates are A, B, C, D, E. The summation is 15,000. 15,000. And what I want to do is minimize the sum of A, who has got the maximum votes, and max votes he has got, and min votes he has got, and A plus B, E, I have to minimize. Because I'm looking for the minimum score. The sum of votes cannot go below this total. The sum of votes cannot go below this total. Okay. So first thing, the person who has come in 5th, let me give him 0 votes. Let me not give him any votes at all. And the remaining 4, let me distribute the votes equally. 3750, 3750, 3750, and 3750. But and by this extension, the answer should be 3750. But that is not present in the options. The closest one present there is 3752. But see this wonderful thing. We were told in any round, no 2 candidates got the same number of votes. So us distributing 4 identical number of votes to these 4 people wouldn't work. So what do I have to do? I have to ensure that this goes down, has to go down by 2, so that this can also come down. This has to become 3748. This has to become 3749, so that this becomes 3751 and this becomes 3752. I cannot push down anything further. I cannot. Can I, as in any reduction that I engage in has to be matched by an increase somewhere, and B cannot increase anymore. It would become identical to A. I don't want to increase because A plus A I want to minimize. Can I reduce A? No, I cannot reduce A anymore. It would become identical to B, and 2 people cannot have identical scores. So the minimum possible summation for votes garnered by the person who got highest votes in round 2 and minimum votes in round 2 has to be 3752. And this is how that working bears out. Okay. Let us now do The next question starts off with, if the winner was decided after round 3 and 10,000 votes were cast in each of round 2 and round 3, then the total number of votes received in the 3 rounds together by the candidate who was not the winner, could not be more than. Okay. So we are looking for a person to gather as many votes as he possibly can, without winning the election. Okay. So what I'll do is, from round 1, who has a lot of votes already? 3160. So in round 1, let this person get 3160 votes. Now in round 2, 10,000 votes are cast. And maximum votes that can be cast such that a round 3 takes place. Maximum votes that can be cast for an individual such that a round 3 takes place is 5,000. Let this person get 5,000 votes, and the other people there will get 4,997,210. Ideally this 4,997 doesn't come smoothly, it comes this way. इसको खूब सारे वोट्स दे दिए, फिर इधर 0, फिर इधर 1, फिर इधर 2. So the second person has got 4,997 votes, 5,000 here, 4,997. So the people who will move on to round 3, 10,000 votes cast here, people who will move on to round 3 are these 3 people. When they come to this round, he has got maximum votes in round 1, he has got maximum votes in round 2. Now I don't want him to win overall. So what is the maximum number of votes that he can get? Let me give 5,001 votes here and 4,999 votes here, and the last person gets 0 votes. If the trajectory of a candidate has been this, he cannot possibly have gotten more votes. 3160 among the initial bunch of people. Sheila got 3160 votes. Then she got 5,000 votes in round 2, and then she got 4,999 votes in round 3. Altogether, how many votes would be cast and what would be the situation? We can simply see that the unit digit has to be 9 among the available options. Only this option has 9 as the unit digit. This would be the storyline. Okay, let us move on to the next thing. If 8,000 votes were cast in round 2, okay, 8,000 votes here, and 12,000 votes were cast in round 3, then the total number of votes received in the 3 rounds put together by a candidate who won the election could not be less than. Okay. So we are looking for the winner. I'm looking for minimum number of votes. The person who has received the minimum number of votes and is moving into round 2 is of course Pravesh. So I'll start off with, he gets 3084 in round 1. In round 2, let him receive very few votes, yet he's moving on to the next round. So he has to be among top 3. So the bottom guy gets 1. The guy above it gets, the bottom guy gets 0 votes. The guy above him gets 1 vote. Pravesh gets 2 votes. And then 3 votes are left. Let the other people get 3,999 and 3,998 votes. Pravesh is having this story, 3084 here and 2 votes here. Now when he comes to the next, remember for round 3, we did not need 50% of the votes to win. We just needed 1 more than 1/3. So the vote distribution here, let it be 4,001, 4,000 and 3,999. Pravesh can happily have this trajectory in his storyline. Pravesh can happily have, in round 1, he got minimum possible vote among the people who qualified. In round 2, he got minimum possible vote among the people who qualified. And then in the final round, round 3, he got just 1 more than 1/3 of the total number of votes. And therefore, the candidate who won the election could not have received less than 3086, 3087, 7087 votes. Or option A is the answer. Okay. And now the last part. Let me get rid of this working all over again. The number of votes received in the first 2 rounds put together by a candidate who reached round 3 could not be less than. I should not have deleted the working. I can bring that working back because that is precisely what we had done for the previous question as well. Look at our Pravesh. The number of votes received in the first 2 rounds put together by a candidate who reached round 3. You are reaching round 3 and you have to get minimum number of votes. It would be for Pravesh in round 1, he has got minimum possible vote, minimum number of votes, and in the second round also. Now see, what has changed is the totals are not present. But can you see, regardless of what total you have here, regardless, minimum number of votes received by the third highest person, whether the total here is 5,000, 8,000, 9,832, whatever it is, minimum number of votes received by the third person in round 2, the person who ends up getting ranked 3 in round 2, will always be 2. So 3084 plus 2, minimum number of votes received by the person who is moving on to round 3 is definitely 3086. It cannot be any lower than 3086. And therefore, the answer to the question is, of course, option B. That is the entirety of this set. In the grand scheme of things, hopefully you also realize the names of the people here are not that important. It is just that they have been associated with a number. So if you can work your way around it, it would be easier. That will be all for this set.